Hello students, in this video I will be going through exercise U3A08, which is taken directly out of the Glencoe textbook. That is a supplemental text that I use in this geometry course. And if you want to look up this text in the Google Drive, you may do so, and it's taken directly out of page 362 to 364. Let's take a look. In this exercise, we are going to be applying the triangle inequality theorem, which then will allow us to then determine a range of different values for a third side. If we know the first two, we can also determine whether or not a triangle will exist based on the side lengths that are presented to us. Let's take a look. So the first questions here, the instruction says, is it possible to form a triangle with the given side lengths? If not, explain why not. So I have here a triangle 5, 7, and 10 centimeters. What you have to do, and it really doesn't matter which two sides you pick. So I'm going to pick at random. Let's say 7 and 10 here. Okay, it could be 5 and 7. It could be 5 and 10. It really doesn't matter. Okay, and what you do, okay, is with that choice that you've made, what we do is we're going to add 10 and 7. And that will be 17. And we're going to take 10 and 7 and we're going to subtract them together. And that will be 3. Now, is that third side here going to be in between that? And if so, then you've satisfied the triangle inequality theorem here. This triangle will in fact exist. So yes, this will exist. I want to go at random, okay? I want to pick 3 and 4. So again, I'm going to add 3 and 4 together, and I'm going to subtract 3 and 4 together. Is 8 going to be in between this? And clearly it's not, because 7 is not greater than 8. It definitely is greater than 1 though, but it's not, but the number has to be less than 7. So this does not work, does not exist. What about this triangle here? And again, it really doesn't matter. I want to take 6 and 14. I'm going to add them together. I get 20. I'm going to subtract 6 and 14 together, and I get 8. And 10, in fact, is going to be in between that. So it does work. So this exists. Just one more comment on this. It really doesn't matter. Let's say if we chose another option, let's say 14 and 10, just to really drive the point home, okay? So 10 and 14 here, what I'll end up with is 24. Subtract 10 and 14, I'll get 4. 6 does in fact work. If I apply the same thing with the triangle here that didn't work, okay? Let's say I choose not 3 and 4, but instead chose 4 and 8, right? If I add 4 and 8, I get 12. Take 4 and 8 and subtract them together, I get 4. You see here, 3 is not in between 4 and 12. 3 is outside of 4 and 12. So again, it doesn't matter which two sides you pick. Any two sides will work here. All right, so let me just erase this. So I chose that. All right. Same idea, 4, 9, and 15, okay? So 4 and 9, I get 13, okay? And 9 minus 4 is 5. 15 is not in between that, so this does not work. And it doesn't matter which two sides you pick. This same conclusion will always come out. Let's say if I chose 9 and 5. If I chose 9 and 5, I end up with 24. Subtract 9 and 15, I get 6. 4, in fact, is not in between 6 and 24. So again, it does not work. All right, so I get 11, 21, and 16. I'm going to pick these two. So if I add 11 and 21 together, I get 32. Subtract 11 and 21 together, I get 10. 16 is, in fact, in between, so this does work. It exists. All right, so I want to take 9.9 and 11. So if I add them together, I will end up with 11. Subtract 9.9 and 11, I get 8.8. 8.2 is not in between it. This does not exist. Does not exist. Let's try it again for number 9. I want to take 2.1 and 4.2. Add them together, I get 6.3. Subtract them together, I get 2.1. 7.9 is not in between that, so it does not exist. Does not exist. So in order for me to compare this properly, I will need to create common denominators. So I'm going to rewrite this as not a mixed number, but as an improper fraction. So this is the same thing as 5 halves. This is the same thing as 7 fourths. And 5 halves rewritten with a denominator of 8 becomes 20 eighths. 7 fourths rewritten as with a denominator of 8 becomes 14 eighths. And the last one here is 41 eighths. So all I got to do is just compare. Let's say I don't even have to compare it as a fraction. I can do 20, 14, and 41 because it's the same multiple, right? So if I compare 20, 14, and 41, if I add 20 and 14, let's say I choose these two, right? So I get 34, and subtract them, I get 6. 41 is way outside of that range there. So this one here clearly does not work. Does not exist. All right. Okay, what about this one here? So, again, I create I'm going to make a mixed number, improper fraction. I get 6 fifths. I get 9 halves. And here I get 15 fourths. So to create the common denominator, I'm going to, I believe the LCM is 20, so I want to multiply by 4, so I get 24 twentieths. The next one I multiply by 10, I get 90 twentieths. And the last one I multiply by 5, which is 75 twentieths. So I'm comparing 24, 90, and 75. So if I add 90 and 24 together, I get 114. Subtract 90 and 24 together, I get, so what is that? That is 66. And this does work, so it exists. Right? This exists. Okay, find a range of the measure of the third side. So this is really, really similar here. So we're looking for the range of possible values for that third side. So it's the same kind of idea. We're looking for a range of possible values. I'm going to add 8 and 4 together to get 12. I'm going to subtract 8 and 4 to get 4. So that means our third side must be between 4 and 12. It cannot equal 4 and it cannot equal 12. It must be within that boundary. Again, the same idea. I want to add 11 and 15 together, get 16. Subtract 11 and 5 together. Subtract 11 and 5 together, I get 6. The third side must be between 6 and 16. Next, I'm going to add 2.7 and 4.2, so I get 6.9. And I'm going to find the difference between 4.2 and 2.7. What is that? That is 1.5? Right. 3.8 and 9.2. So add 3.8 and 9.2 together, I get 13. Subtract 3.8 and 9.2 together, what is that? 3.8 and 9.2. I'm getting really lazy. Let's see here. 9.2 minus 3.8. So that's 5.4. Okay, 1/2 and 3 1/4. So 1/2 with a denominator 4 is really 2/4, and this is 3/4. 3 and 1/4 is 13/4. So I want to add them together, and that will be 15/4. Subtract them together, I get 11/4. So x must be in between those two values. Same thing, this one is even easier because the denominator is already the same, so it's 7/3 and 23/3. I add them together, it would be 30/3 or just 10. Subtract them together, I get 16/3. So x must be in between those two values. Find a range of possible measure of x if each set of expressions represent measures of the side of a triangle. This is pretty much the same idea. So x is going to be between 10 and 2. X here is going to be between 20 and, what's 12 minus 8? That would be 4. And then I have this guy, x plus 1. So here, and again, it's really no different. So I take x plus 1. It's got to be between 7 plus 5 is 12. 7 minus 5 is 2. So therefore, if I subtract 1 from either side here, I want to get x is less than 11, or it's going to be greater than 1. I got to subtract 1 from either side, okay? All right, same idea. X minus 2 has to be between 22 or 2. I want to add 2 to both sides, so I get x is in between 24 or 4. Last one. Okay, so don't be afraid. We're going to treat this the same way. I want to pick these two, okay, as my range. So let's check this out. So x plus 2 must be less than 2x plus 10. While at the same time be greater than, if I subtract x plus 6 and x minus 4 together, I'm going to end up with 2. Right? Subtract x plus 6 and x plus 4. Right? Okay? So if I do this, okay, really it's just two different inequalities I need to solve. So I have x plus 2 is less than 2x plus 10. If I go through this, okay, and I subtract x from both sides, I get x. Subtract 10 from both sides, I get x is greater than negative 10. I'm sorry, negative 8. And then I do this one right here. 2 is less than x plus 2. Subtract 2 from both sides, x is, so I got 0 is less than x. So what is the final answer then? X is greater than negative 8 or x is greater than 0? Well, it has to satisfy both of these. Okay? So in order for this to be true, we cannot have the range values here. It must be the only solution that works is x is greater than 0. Not because x has to be a positive number. X can be a negative number, but it's just that this one satisfies this condition as well. Okay? So, I mean, if what I'm saying doesn't sound convincing, try putting in, let's say, negative 1. If you put in negative 1 in here, right, you'll end up with, or actually put negative 1 in here, rather. If you put negative 1 in here into all of these, you'll end up with 1, 3, and 5, right? Can 1, 3, and 5 work, right? If you add 1 and 3 together, you get 4. You subtract 1 and 3, you get 2. 5 does not work, right? So this is a demonstration of the mathematics, right, that x must be greater than 0 only. Not because x can't be a negative number. It can be a negative number. It's just that the final answer has to satisfy both of those conditions. Okay, so same thing over here. We're going to do the same thing. I'm going to do 2x plus 1 plus x plus 4. What do I end up with? I end up with 3x plus 5. If I subtract 2x plus 1 with x plus 4, I end up with x minus 3. And x has to be in between these. So I'm solving for x minus 3 is less than x. So if I do that, okay, I'll end up with negative 3 is less than 0. So that works. Any value of x will always work for this, okay? So any value of x will work for that. However, I still have this side I need to do. If I subtract both sides by 3x, I end up with negative 2x is less than 5. Divided by negative 2, I then have to flip the inequality symbol. X has to be greater than negative 2/5. I'm sorry, negative 2.5, or 5 halves, right? So here, x is any real number will work. Here, x must be greater than negative 2.5. Which one will actually satisfy everything? Well, it has to be greater than negative 2.5. Okay, anything lower than that will not work. So for instance, if I substitute in, let's say negative 1, right? Let's try substituting in negative 1. Or actually, we can't have negative 1 here because this side here, okay, it's only x. Because it's only x, okay, I cannot have anything below 0. It cannot be 0. It cannot equal to 0 either. So actually, to satisfy every condition, because x is greater than negative 2.5, x therefore, in order for all this to work, must just be greater than 0. That's the final answer. This will satisfy everything. Satisfy all conditions. Okay.